Hello, welcome to the second episode in Agentic Horizons. I'm going to talk about the article I wrote and the models that were released last week. The main news for the week is centered around model releases. Last week was dominated by Qwen. I had an article where I talk about the three musketeers of Qwen 3. They released three models, one specific for coding called the Qwen 3 Coder, one specific for reasoning that has reasoning traces inside of think tags called Qwen 3 Thinking, and then one general purpose non-thinking model which responds quickly since it doesn't have to output the reasoning traces called Qwen 3 Instruct. These three models are revolutionizing, I know it's a strong word, but they are revolutionizing the landscape and the economics of frontier LLMs. The gap between open source models and proprietary closed models has been pretty much closed. When you look at comparisons across several benchmarks, and we can see that in some benchmarks, Qwen 3 models are actually higher than proprietary models. Or in some others, they're neck and neck or slightly below, but they're extremely competitive. And what's really notable are the differences in pricing from APIs and the fact that they're open source so that they can be locally hosted. One point of differentiation from Kimi K2, which I've been excited about, is that these Qwen 3 models are even smaller, which means that it's even more accessible for people to run on local hardware. And also, it means that the inference costs are even lower, which I'm going to get into in detail. So in the article, I talk about each of the three models. The coder model, which is specialized in agentic and software engineering tasks. The reasoning model that encloses the thinking inside of the think tags. This is especially good in order to see thinking processes in action, as in with my CLI engineer tool. These things can run for an hour or sometimes extended periods of time. So being able to have some traceability and some transparency to the thinking process is very useful. And the third model is the general Qwen 3 Instruct model, which is able to answer quickly without reasoning traces and still has very high performance across various question answering and problem solving benchmarks. You can see the size between these are comparable. The thinking and the instruct model are both a mixture of experts models with 235 billion parameters, but only 22 billion activated per token. And this has an implication for inference, because even though you need to have all of the models loaded into memory, you only need to execute the processing for the activated parameters. This means that it doesn't affect the minimum hardware requirements for VRAM or unified RAM in order to load the models, but it does affect the economics of how much compute do you need in order to run these models and in order to run them quickly. The coder model is heavier weight. It has twice as many parameters, 480 billion. It's up there with giants like Grok, not quite as big as the 1 trillion parameter Kimi K2 model. So having half the parameter size has a considerable impact into the hardware requirements. And then 35 billion parameters are activated per token for the coder model. As I mentioned, these are a mixture of experts models. This has become the dominant paradigm for LLMs, especially the open source ones. It's going to have a profound impact on the ability to democratize access to these with advances in hardware and being able to have quantized versions of these run on even lower hardware requirements. As far as context window, One of the main benefits of the Qwen 3 models is a rather generous context window. They have 256K context out of the box natively, and a 1 million token context window is possible through what's called a yarn extension. I haven't seen this available through any providers currently through APIs, but if you're going to look at a self-hosted solution with considerable hardware rig, this is something that would be available. For enterprise coding use, this definitely makes it an interesting contender to look at a high-end model that is able to do state-of-the-art reasoning and coding with the largest context window practically available. I know a while back, Llama 4 came out with a 10 million token announcement for Llama 4 Scout, I believe it was, not Maverick, but Scout. But I, again, did not see that available through any provider, and I think the hardware requirements for that would be extensive. Given its performance, there hasn't been that much interest in exploring that kind of long context. I haven't seen any other model get even close to that. At some point, it could be worth exploring, but right now, the 1 million token context is the practical leading edge. I'd be really interested to see this yarn extension put into practice. As far as the multilingual training data, this is a highly multilingual model. It has been trained extensively on 119 languages and dialects and has a special focus for non-Latin, which has been underrepresented in many other models. So Arabic and Chinese have a higher representation here. And it is really good at what is called code switching, which is switching between languages in the middle of a task or a phrase or a context. This means that translation tasks are going to be especially well handled by this model. This is interesting to me because I'm looking at a lot of multilingual applications in order to provide international reach. And I'm looking at different models for parts of content creation workflows. I think this is an important thing to consider. As far as the benchmarks, each model has its own focus and its own strengths and weaknesses, but they all stack up very well. There's numerous aggregated benchmarks across different models. One problem with benchmarks is often it's hard to get an apples to apples comparison of leading frontier models because they don't include some of those models across the various benchmarks, or the benchmark data isn't available. But for apples to apples comparison of benchmark capabilities and economics, I decided to highlight a couple of things. One is this Super GPQA, which is a benchmark for question answering. This has been one of the most recent benchmarks that incorporates various disciplines at the graduate level. And for this benchmark, interestingly, we can see that the thinking model is neck and neck with Gemini 2.5 Pro, or even slightly edging it, considerably ahead of Claude for Opus for the HMMT, which is a Harvard-MIT math tournament, and considerably ahead of Claude for Sonnet, since Opus data wasn't available, for the Super GPQA. So we can see that we have an open source model now competing with and considerably beating these proprietary commercial models that are fairly expensive. Gemini is quite a bit more affordable. Anthropic, I think, has to do some soul searching because their pricing models are not sustainable given the benchmark comparisons and the pricing of some of these open source models that are coming out. Which leads me to the price tag. One of the considerations is the architecture and the quantization and memory requirements and the ability to have these models run on different kinds of infrastructure for local use. This is relevant for people that want to have private processing of data or not be dependent on third-party cloud providers. But it's also relevant, as I'll get into later, for the economics of inference by different providers. Looking in a general sense, I'll do a closer look later into the API pricing. Qwen 3 thinking has an amazingly cheap $0.118. We're talking cents per million tokens of input and output. The other models are a little bit pricier. We're talking 30 cents, 12 cents per million tokens input. And then the output does get a bit more expensive there. We're talking $1.20 for the coder model, 59 cents for the instruct. But these are such orders of magnitude below the commercial pricing. It's hard to appreciate that. So I tried to show this visually, comparing the same models that I had here. Qwen 3 thinking model, the Gemini 2.5 Pro, and Claude for Opus and Sonnet. We can see how the input and output pricing compares. No matter how hard you squint, I don't know, there might be a single pixel line there. It's pretty much invisible. It looks free. Mostly because Claude for Opus is so outrageously priced, so incredibly outrageously priced for the output. We're looking at $75 per million output tokens. So I decided to remove Claude for Opus and look at a comparison chart just with Gemini 2.5 Pro and Claude for Sonnet. And now you can see a little bit of color there, but it's still practically invisible. You still have to squint. So this should help to really communicate the economic impact of these models coming out that are neck and neck, sometimes even slightly better than some of these proprietary models, and several orders of magnitude, like 0.15% the price of these leading models. This definitely changes the equation. So this has geopolitical implications. We are looking at the effects of the technology restrictions to China. An interesting thing that arose that was displayed by DeepSeek R1's model release at the beginning of the year was that by forcing them to be more efficient because they didn't have access to the most powerful GPU hardware, they found ways of being ingenious with the architecture and doing more with less. It's an interesting thing that basically backfired, I think. If you look strategically at export restrictions and the net effect that they had, we see that what ended up happening was more efficient models were developed to make use of less performant hardware, especially for the training, but also for the inference. And as a result, we have these waves of effects in the economics of model inference, starting with DeepSeek R1, then Kimi K2 did a major upheaval, and now Qwen 3 is putting the nail in the coffin. The economics are amazing. So I think we'll have to think about what comes next. We're looking at reimagining of business models or of strategy. It's interesting to see where that will go. But ultimately, it's going to end up benefiting the world. It's going to benefit consumers, and it's especially going to benefit startups and businesses in developing economies, since they will now be able to compete with access to frontier LLMs at orders of magnitude cheaper pricing. That's the main news that came out last week. There are some other interesting developments also in model releases. It's one of the main categories of interesting events in AI. So I'll briefly talk about them. One was Apple Intelligence. They're interesting mostly because they hadn't been doing something for so long. They've been going through upheavals, changes in leadership. They had to backtrack a lot of promises that they made about what Apple Intelligence was and what they were able to deliver. Now they're starting to come out with something. It seems like there's some life there. They're working on two things in parallel. One is what they call a parallel track mixture of experts that are large language models for running on servers. And another is for edge devices. We're talking 3 billion parameter models optimized for Apple Silicon. This makes sense. They want to have models that run on device on iPhones, maybe on laptops as well, or tablets. And this is going to affect the edge computing capabilities of these devices, which will allow the devices themselves to be competitive. This will give them a hardware competitive edge, and it's interesting to see that they're prioritizing that. So I'm happy to see activity on that front. We'll see what that translates to as far as the product pipeline, but it seems like there's some activity stirring there. Another interesting model that came out was UiTars by ByteDance, the company that owns TikTok. ByteDance has done a lot of work in AI, extensive work in AI. And this is an interesting model because it's specialized for computer control and automation with visual understanding. So this is going to be a great model to plug into browser use or any other agentic browser automation and computer automation models. I'm going to be excited to take it for a spin. One of the things I've been wanting to explore is going beyond web searches and deep research that just analyzes information retrieved through APIs and into computer and browser automation that will allow deeper interaction with interactive websites that require configuring filters. And in addition to the research use case, the taking actions on your behalf use case, like booking tickets, making reservations, taking these kinds of actions are things that these kinds of browser automation agents are starting to be able to deliver. So having models that are specially designed and built for that use case is very interesting and promising development. Aside from general purpose reasoning models or even vision language models, having models that are designed for computer control and automation is an interesting thing. So excited to play with that soon. And then finally, there's a new model that dropped today, just a few hours ago, called GLM 4.5. This is from basically a new player that I'd never heard of. I think many people never heard of them. They're calling themselves Z.AI. They were originally a different organization called, I think, ThudM. They said they were going to continue to release academic work under the ThudM organization, but they just set up brand new organizations on GitHub and Hugging Face. So brand new player in the AI space, and they're turning heads because they are pushing the envelope even more. Interesting to see. Just a few days ago, wow, look at what Qwen is doing, and it seems you can't stay on the leading edge for too long these days. There's some caveats to some of the things, and I'll get into some of the context and pricing, but at a glance, I'm very happy to see that they're comparing against O3 and Grok 4. This is something that I've yet to see many other open models do. So they compare against O4 Mini, but it just leaves you to wonder, how does it compare against O3? Very happy to see that transparency and happy to see that the gap is very small. They're pretty much neck and neck with Grok 4 and just ever slightly behind O3. This is on an average or a weighted average. I haven't looked into the exact formulas that they use to combine all these benchmarks, but these are 12 different benchmarks, and they're combining all of them to compare all these models, including the most recent models like Kimi K2 and the frontier commercial models like Opus and Grok 4 and O3. And this model is right up there. In fact, in agentic tasks, this is doing extremely well. If you look at a subset of these in TauBench, now TauBench is an interesting benchmark. It's a moniker for a TAU, Tool Agent User. This is a benchmark that was designed specifically to look at interactions between a user and an agent and the agent's use of tools. This is extremely relevant for things like computer and browser automation, as well as software engineering, where you're interacting with an agent and the agent needs to make use of tools in order to better carry out its duties. It needs to be able to connect to data sources or look up documentation. So in this benchmark, we can see that it is neck and neck with Claude 4 Sonnet, and it is beating other models, including O3. This is another wrench in the economics. It's interesting to see how these open source models that are running with leaner requirements are upending the dominant paradigm. They're trying to do a Pareto frontier on a SweBench verified score versus model parameters, but the model parameters doesn't take into account how many activated experts there are, or activated parameters, or the real pricing on the inference. You could say that you could extrapolate from activated parameters to cost per token, but it's not a totally direct Pareto frontier comparison. Still, you can see that compared to the Qwen 3 model that was just released, that was 235 billion parameters, they have a lightweight model that has a much higher SweBench verified score. And then their main model has an even higher score. Now, their main model is neck and neck with Kimi K2 and Gemini 2.5 Pro, slightly behind Sonnet. But again, what is very interesting is compared to Kimi K2, which is 1 trillion parameters, we can see the GLM 4.5 is at 355 billion. So that is about 1/3 the parameters of Kimi K2. And then their lightweight variant is even 1/3 of that, 106 billion parameters. So we're looking at 1/10 the parameter count of Kimi K2. And at 1/10 the hardware requirements, we're seeing almost comparable SweBench verified. This means it's going to greatly democratize, on the one hand, inference costs for inference providers and accessibility for professionals and small enterprises to spin up hardware to run these models locally. So that is a very interesting thing I did not expect to see when I woke up today. Now I want to get a little bit deeper into what these inference costs are. I'm talking about the different providers through OpenRouter. And you can see what effect some of these different characteristics of the architecture have. One thing a lot of people don't realize who use OpenRouter is just a router. It routes requests to different providers. I think people realize that, but what they don't realize is that the different providers can have drastically different cost performance characteristics. So if we look at Kimi K2, you can see that Moonshot AI, the creators of Kimi K2, they have floating point 8, so that's what you consider like maybe 1/4 accuracy floating point operations. The lower the accuracy, the quantization, the less accurate computations there are, but the faster and the cheaper hardware is able to run them. So you can see their input and their output costs are considerably lower than some of these leading models, but we're still looking at maybe half order of magnitude, so to speak, $2.50 per million output tokens. However, if you look up at some of the other providers, Shoots is leading the charge in cost performance ratios. They have 0.13 for both input and output. If you're to compare apples to apples, this is the same model, this is the same quantization level, the precision level, and this one is based in the US, so people that are concerned about sending tokens to China can have those concerns alleviated. What is different, however, is the context window. So this is why I said the 10 million token context window in Llama 4 has not been realized. This is something that as you scale inference to serve multiple users, the longer the context window, the much steeper hardware requirements you're going to have. So you win some and you lose some, you can provide much cheaper price, but at a lower context window. If you want the full 131K context, you can look at something like Deep Infra. They do have lower precision. This is an FP4 quantization, but the prices are pretty much in line with Moonshot. So at this point, the only thing that you're really getting is you're able to keep your tokens in the US. You're also able to get faster throughput. All of these things affect each other. The quantization level, the throughput, the context window, and the pricing. All of those are in dynamic tension with each other, so you can calibrate depending on your requirements. OpenRouter actually allows you to specify either in order which providers you want to use or what you want to optimize for. Do you want to optimize for pricing or for throughput, etc.? So that's an interesting consideration to have in mind. Also, as far as the pricing, when we're looking at these pricing comparisons, let's look at the Qwen 3 thinking model. I mentioned 0.118. This is, again, through shoots. And this is the full model, no quantization. This is the full context window. But compare that to the direct API pricing through Alibaba, and you can see the enormous difference. We'll refresh and see if there's any changes here. Yeah. They have a less uptime. They've only had a 23.5% uptime today. So they're having some availability issues. And I think maybe related to that, their price went up. I thought I remembered seeing this lower. So you can see the difference here is about 80 times cheaper. In order to really realize these order of magnitude gains, it's important not just to choose which model, but to choose which provider you're going to use. Look, on top of that, you get twice the context window. This is a compelling reason to use shoots instead of going through Alibaba's API directly. Makes you wonder why they're charging that. I don't know. I can speculate that it may have to do with access to hardware, and that maybe some of the more advanced hardware in the US can have better cost efficiency of dollars per floating point operations per second. Maybe it's economies of scale. But it is very interesting to see that in China, where electricity is cheaper, the providers that create these models in the first place are not able to compete on the international market for a pricing advantage. This is an interesting twist on this democratization of access and on China becoming a dominant leader in releasing these models. But when you look at where you do your inference, the people that are going to make money processing people's tokens are going to be the people that can provide that best combination of what is your precision quantization, what is the size of your context window, what is the pricing on your input and output tokens. It's interesting that some providers have the same pricing for input and output, and some for the same model have drastically higher pricing for the output tokens. And then the latency and the throughput. All of these requirements, which I mentioned are in dynamic tension in opposition to each other, are going to determine the provider's competitive advantage when looking at what people choose or what gets automatically routed for them. So that is a very interesting thing to be aware of. I think that if you're using these models through OpenRouter, you want to specify the provider that you want to use, depending on both the characteristics of the different providers for that model and your use case requirements. Do you need speed, or do you need large context, or are you mostly concerned about the price, or what combinations of these factors matter to you? So looking at that, The GLM 4.5 model is not quite as dethroning of a development for Qwen 3 as you would think. They have a smaller context window. They have considerably higher pricing, so we're looking at 10 times higher for the output tokens, and slower throughput. This could be because nobody has started serving them yet. We don't have people that have loaded this model like Shoots and Deep Infra and see if they can provide better economics. And maybe it's just a matter of days. But we'll see. We'll see as other providers start to come online and serve these models. What is interesting is that the light model, again, is called the Air model, has a smaller footprint at, I think it was 105 billion parameters. This is starting to get into the space of consumer hardware. And so this is something that people are going to be able to run locally as opposed to Kimi K2. Now, some of the Qwen 3 models with Unsloth's dynamic quantization are able to be run on high-end consumer hardware. But having something that is 100 billion parameters is a lot more accessible. So that is an interesting sweet spot to target for today's hardware market. So that is pretty much what has been happening from the last week until just a few hours ago in the space of new models and how the economics of model serving and running models locally is unfolding. I'm very excited to try some of these models, both through inference providers, and maybe I'll spin up some beefy machines and run them locally and see what that experience is like. So until next time, that's it.